The great thing about stressing about something and then succeeding is that when you decide to take a break from it, you truly feel like you deserved it. And once you jump back into the fray, your motivation and morale gets a huge boost because you end up missing the process. The month of August was a month I set aside to take care of some debts that were hanging over my head, including several unpaid tickets, assessment fees, tolls, and personal debts to others that I had neglected in the interest of making sure this build went on unhindered. This coincided with this temporary boost in work hours that I'm in the middle of after one of my coworkers had transferred from my location. It's bittersweet that I am, losing all this time to my own craft for a corporation, but at least the extra funds helped expedite the process of clearing up my debts. But anyway, what you're looking at is the teardown footage from a musical Patreon video that I uploaded several weeks ago to show a few supporters that things were in motion now. Now, you've all seen me take this bike apart and put it back together enough that I don't really need to spend too much time on this. On the other hand, knowing that this begins the final phase of the build series where things will start getting pretty and finished in terms of colors and shininess, I figured that I should probably go ahead and buy a cheap little rinky-dink workbench. It's the Wen multi-purpose workbench from Amazon, and I only paid about $100 for it. Now believe me, you get what you pay for with this thing, and it ain't gonna impress anybody in terms of build quality. But the reason why I went with such a cheaply made bench is because I plan to leave this thing outside exposed to the elements, because I'm gonna use it for things that you probably shouldn't do indoors, like painting and sanding, and also I don't even have the room for this thing inside anyway. I mean, the metal body should hold up because they're at least painted, but this cheap compression board top is probably not long for this world once it starts getting rained on. If anything, I could just replace the top with hardwood when it comes time. But yeah, there's my cheap little bargain bin workstation. Yes, one of the drawers broke immediately. Don't laugh. I also bought a lithium battery charger to revive that anti-gravity battery that died out while I was trying to get the K100 to start a couple episodes ago. Now, the real fun began when I took the frame and finally started the process of removing all of the electrics from it so I could finish angling the tail and then get it powder coated. The frame sitting there might look like an absolute incoherent mess, but given that I had been unplugging and plugging and unplugging and plugging this shit over and over for the past few months, I pretty much know what 95% of these connectors go to, and plus, with the way that everything was situated on the frame, I could use context clues to label everything before I removed the harness. So got to work with labeling the connectors. You'll have to excuse my handwriting because it's pretty hard to write on electric tape when it's backed by nothing. This little bolt is the ground point for several electrical components, which will come in handy for the rewiring process. For whatever reason, BMW uses brown for the ground or negative cables instead of black, which is something to remember when working on these bikes. You truly take the good with the bad though, because BMW was actually gracious enough to make the fuel injection wiring a standalone plug-and-play harness. So the connection to the temp sensor, the fuel injectors themselves, the throttle sensor, the injection brain, and the airflow sensor are all one thing, which makes lives very easy. Unfortunately, that is not the case when it comes to the ignition system, which we will definitely see. Eventually everything was labeled and was ready to come off the frame with that big doofy relay and fuse box, the bane of my existence. Now don't worry, we're gonna make that ugly thing history. But at this point, my plan wasn't really to touch the electrical stuff at all, but to instead focus on the frame only. So I shifted my focus back onto the frame and continued to remove anything that would be in the way of the powder coater. That right there is the brain for the ignition system, which works in tandem with the injection brain. So this is what I was left with. The completely bare frame itself, with all of its rust and blemishes waiting to be made shiny once again, the ignition brain, the injection harness, some frame hardware, a frame damper for the tank, the coils, a battery strap, the coolant overflow tank, the harness tray, and the main harness. I boxed up everything and tucked it all away with no intentions of touching that stuff anytime soon, but it only took one day before I started to feel like I needed to actually do something. Immediately I found myself tinkering with the main harness in an effort to cut it down to bare essentials. As I already mentioned, I plan to run this little gadget called the M unit, where basically all of the lighting and stuff is handled easily by a fuseless and relayless little brain. So soon the K100 will have 3 brains, like a cow or something. But we'll talk about the M unit later in this episode when I actually have it in my hands. For now, my goal was to simplify the harness to the absolute bare essentials that this bike needs to run, which includes also killing off the fuse box and a vast majority of the relays that you see in this box right here. So immediately I had to familiarize myself with what relays were what and label them for my sanity. This is the placement for all the relays within the box for non-ABS 8-valve K100s like mine. So I just me and Ginger labeled them accordingly. Now, like I said, the M unit is fuseless and relayless, so if there was any function that I wanted the M unit to control, like the horn, the lights, and the signals, I X'd out the corresponding relay to let myself know that it was okay to remove. Load shed relay is basically what turns off things like the headlight to give maximum load to the starter when you're trying to start the bike. The bulb monitor is this super unnecessary system that senses if you have a tail light, brake light, signal, or headlight bulb burnout, and it brings up a light on the dashboard to tell you. The horn and flasher relay are pretty self-explanatory and they can go as well. Now, the fuel pump relay, the starter relay, and the temperature sensor relay that works the fan we're obviously going to keep until further notice. Now, with that in mind, and with all of the labels that I made, I got to work cutting down the harness, and what immediately became apparent is just how complex and interdependent these electrics are. The ignition and the injection, along with all other extra systems, really just create this mess of spaghetti, especially for someone like me who doesn't have that much electrical experience. I mean, really, I tried to be methodical and attack things one by one, but you end up tracing these wires back to places that just don't make any immediate sense, and you're just like, what is this shit? But I realized that what you really have to do is just remember your ultimate goal with the harness and just cut. That's it. Just start cutting that shit. But, obviously while using some common sense. In this case, I only needed one thing: the injection stuff, and the 3 relays that I mentioned that I'm going to keep, obviously. Naturally, as the pile of cut wires grow, what you're actually looking at on the table becomes smaller and smaller and things start to become more clear. Now, that night I had reduced the harness down to something that I was happy with, but ultimately the anxiety of not really knowing for sure if I had ruined the harness was bothering me a little bit. Like, it looked like it would work, but how would I really know for sure until I actually wired the bike completely, which would be weeks from now? So instead of waiting that long not actually knowing if it would work, I had remembered that a fellow K100 builder by the name of MikeyfromPiha. He's a builder here on the YouTube land, and he offered me his wiring diagram upon learning that I would be going with the same M unit route as him. So I ended up taking him up on that gracious offer, and I spent some time comparing my setup to his diagram. And that's when I realized how good of a job that I had somehow done when comparing it to someone who was essentially a pro with electrics. Simply put, the only difference between my harness and Mikey's was that I kept the temperature sensor relay and the fuel pump relay, which apparently I don't actually have to. I kept them as a precaution just in case, but otherwise, I didn't get rid of anything that was essential out of this whole mess of wires and stuff, which is not bad at all for the first try. Now, this minimized harness will work in conjunction with the plug-and-play injection harness that I mentioned earlier, and I know this because, well, Mikey's bike works just fine with that setup. And you can actually see his bike in action on YouTube in his highly informative 50-something video build series. Thanks again, Mikey. You're an absolute legend for this assist. Now, later on in the build series, I want to return to this for the sake of showing the setup in more detail. Probably in the next episode, maybe, because right now we're not too focused on making a bike run with the mini harness, considering the K100 is in literal pieces. But when the time comes, I will show this in greater detail, no doubt. But the fun middle school science project part was about to be in effect, because now with the frame bare and the lithium battery fully charged, it was time to create a test rig for the M unit, which was at this point on its way to us.
Mail time.
The mail's here. Come on. Bye, guys.
So this is the M unit, which is much more compact than I thought it would be. It comes with a battery cable, some terminals, and hardware. I got a set of M switches for the handlebar, but obviously I need to get another one for both bars. I picked up a keyless RFID ignition switch that would be easier to mount and hide somewhere over a normal keyed ignition, but we'll cover that when it's relevant. I also picked up a wire kit made specifically for the M unit. Now you can use any wires, but these are optimal width and color for the M unit setup, so really I don't have to think that much about it. Though apparently I wasn't thinking enough because I ordered 2 wire kits instead of 1. Anyway, this is another Patreon update video that I posted a few days ago where I conducted my first trials on the M unit. Right, so as you can see, I have a bunch of stuff laid out on this table. So this mess of wires is what the finished product of me cutting down the original harness. Right here I have a couple things that I just had laying around. So this is a horn from the Honda Rebel. This is some turn signals, some LED turn signals that I had laying around. This is actually the headlight that was on the K100 for the past couple weeks that I ran. This is actually a bobber tail light from the Honda Rebel, which has a integrated plate light. And these are turn signals from the Honda Rebel. This is actually the original one. Now the main thing is this thing right here. This is called the M Unit Blue. So what the M Unit Blue does is basically it has on this side a bunch of inputs. So you connect this side to different the switch buttons that you have on your handlebar, or your brake light switch, all these different things, and then they come out through the outputs on this side. So you have the battery positive and then 2 grounds. The ground connection is actually what you use to bolt it down to whatever you're going to bolt it down to. This thing is pretty cool because it has a lot of like Bluetooth connectivity features, so you can connect it to your phone, which gives you like a keyless go feature. But basically what I use this for is because it allows you to get rid of the fuses and the relays. So that giant box that I had on the BMW, I can get rid of that. And you'll see more about that in the actual full episode. But M Unit Blue, you can look it up real quick to watch a review or something. But this is a little sheet of aluminum that I kind of rigged up, because what this is basically what held the electronics in place. So it basically held most of the harness. So that's how it sat in the frame. And this whole surface is what held a lot of the wires and connections and stuff. But it's plastic, so it can't really ground anything. I basically traced out this tray of aluminum, which serves as a pretty good ground. And I traced out all the places where the frame beams kind of prevent me from mounting anything. So that's what it looks like with that plate of metal mounted in there, which is zip tied, because this piece of plastic is actually only zip tied to the frame. I was thinking to mount it right there, because a majority of these inputs are going to be coming this way to the handlebar, so I don't really have to do anything funny with the routing of these wires. But these I'll leave on the outside because I have a little bit more playroom, See, it says GND as ground, so I can actually ground the battery through that, and then this whole plate will be grounded and everything will work, theoretically. So that's what it looks like mounted up. As you can see, it's bolted down good, it's not going anywhere. So what I'm gonna do now is I'm gonna take this plate out and then just kind of run some practice circuits on those appliances on the table over there. When it comes to the positive cable, they actually didn't put the loop terminal on this end. That's because they want you to cut it to whatever length you might need, but I'm not going to cut it. I'm just going to unsheath this wire and then crimp this on there, and then use some heat shrink on this like they did with this one. So I run into the first issue, and that's when I connect the negative, all the lights flash. Now I read online that means that the battery is too low, which is strange because I charged it yesterday. But I'm gonna go grab the battery off the FZ1, which I know isn't dead. And I'm gonna plug that up here. See what happens. So I realized what the problem was. It's not actually a battery, although this is the battery from the FZ1. So keep an eye on the M unit when I attach this negative cable. So you see how every single light on there lights up? The problem is that I need to give the lock input, which is all the way on this side, I need to give that power from the positive. So normally that would be through an ignition switch, but I'm just going to use this wire for demonstration purposes. Okay. Now I'm going to reconnect negative. You should see the lights flash. This, which is our ignition switch, I'm going to touch it to the positive, and it works. So the lock input is on because it's getting power. I have to basically rig this up to where this stays, so that I can get my lock power. So right now, what's active is auxiliary 2 and the ignition output. So this would be the fuel injection or whatever else, fuel pump, all that different type of stuff, and whatever else you hook up to auxiliary 1, which you can actually change if you don't want to get output power when you turn the lock. So yeah, I'm gonna rig up some loop connector so I can loop this and then have this stay by itself, because if I let it go, then it loses power to the lock. So I'll be back with that. So now we got 12 volts going to the lock input. If our camera would focus. So we got 12 volts going into the lock input, which means that everything is operational. So basically the way this works is for the inputs, all the M unit needs is a ground signal, and that's what gives the outputs power. So there's not actually electricity flowing through this from the switch to the actual appliance. If I place it in there and I tap it against the grounding plate, you see, what is that, yeah, that might be like the light, the high beam. But when you tap it against there, it's the same effect as using a handlebar switch, basically. And that basically tells the M unit to activate whatever the input is connected to. So my camera's dying, but let me just give you a quick demonstration of how this thing actually works, right? So you got the turn signal right here, positive and negative. Red is positive, black is negative, obviously. Runs all the way through. So you ground the negative to the ground plate, and then you send the power wire to, my camera does not want to cooperate. So I got that sent to the left turn signal, right? Now that's the output going to the light, obviously. And then we have the input on the left turn signal, which is this wire right here. Now, like I said, grounding this wire is the same effect as hitting the switch on the handlebar. It's the same exact thing. Now I could wire a switch into this because I actually have some here, but this is a much cleaner demonstration of how it's supposed to look, right? So if I connect negative to the battery, the M unit turns on. The lock input already has a 12 volts, so it doesn't have to do the little cycling thing. But if I ground this, the turn signal comes on. So essentially, I'm going to do this with every single thing here, just to make sure that, you know, for my knowledge, I know how everything works and how everything is supposed to light. So if I tap this again, that's like me hitting the button on the handlebar. It turns off. Turn it on again. Turn it off. And the M unit shows you that you press the input, and then the output flashes at the same rate as this. So this brain is basically controlling how fast this flashes, which you can actually configure. You know, if you want a strobe effect, or if you want like a gradual light effect, you could change it within the app or within the setup for this thing. So turn that off, and basically it's going to be the same thing for The headlight, the horn, tail light, license plate light, turn signals. I could wire the ignition, but this little hot wire setup I got going on right here, this is fine. It's a little late, so I might just go to bed, but you know, when I get more chances to work on this, which should be tomorrow after work or something, but right now I'm a little bit tired and hungry. So I did go to bed. But the next day, I proceeded to create a little science project test rig so that I wouldn't be fumbling around with those lights and those wires. It was as simple as taking that leftover piece of aluminum sheet and just drilling and bolting all the stuff to it. Meaning, all I had to do now was wire it up, which was the actual interesting part. I ended up using some cheap sticky-backed LED turn signals instead of the old Honda ones, as they were easier to mount here. I started off the wiring by stripping all the wires involved, and then creating a common ground connection for all of the ground or negative wires for the front 3 lights by simply twisting them all together, and then grounding them to the hypothetical chassis by connecting them to an alligator clamp. I then did the exact same thing for the rear lights. Remember, black is negative, and in that one case of the headlight wire, so is brown, because that wire is from the BMW, which we established earlier, remember? Hope you were paying attention. So all the ground connections meet at a junction with the alligator clip and will ground together in one clean, simple spot on the plate instead of having 6 individual ground connections. So with this setup, we have 6 into 1 and then 1 onto the actual grounding surface. With the negative connections made, it was time to switch to the positive or the power connections, starting with the turn signals. So I did a quick and dirty splice just to get them wired up to the left turn signal output. Of course, when you're actually wiring the bike, you'll do something much more needed than this, but for the sake of the demo, it works just fine. Now the wires for the 2 right side signals. The headlight, the high beam, and I plugged the taillight into the auxiliary output for now. The horn, I had to just run some raw wires to it because I don't actually have the actual connectors for it, but of course, wires work just the same. By using that simple single wire to ground on the inputs yet again, I didn't have to wire up 7 buttons and switches and make it confusing for people watching. When it comes to the M unit, hazards are turned on by hitting the left and the right turn signals at the same time. You cycle between low and high beam and off actually by holding the button for different lengths of time. In the horn button, when you hit it 3 times on startup, it'll allow you to configure the buttons and all the sorcery, whatever's going in there. Basically a configuration menu. It's a very impressive little thing, and I established that I'm totally capable of wiring this thing up. Once I buy all of the controls and the lights that I plan to get, we'll revisit this thing for sure, but next time it'll actually be on the bike. I can't wait. So the next thing in need of attention was the front end, mainly the fork legs, which were leaking pretty bad ever since I got them. So I purchased that Racetech fork spring compressor tool in order to take them apart easily, instead of the cheaper one. It's basically a stand that will compress the forks and hold the internal spring, allowing you to reach this pesky lock nut that is otherwise unreachable unless you have the strength of 10 Hulks and compress the thing yourself. But before that, it's important to loosen the cap of the forks while it's still in the triple, because if you're like me and you don't have a table vise, then good luck putting all that torque on it while you're holding it with your hands. You'll sooner just mess up your wrist doing that. Next, you back out the preload all the way and you can start working on the forks alone. With the cap already loosened, we can easily just pop it all the way off and drain the oil. By this point, I had already done the first fork, which is why there's already oil in the bucket, but this second fork had next to no oil in it, which pretty much shows just how long this thing was probably leaking before I got it. The next step is to get the fork onto the stand and have it grip the preload spacer. Once it's settled into those 2 holes on the side, you just ratchet the stand down until that lock nut for the fork cap is exposed. Then you just attack it with 2 appropriately sized wrenches. Once you do that, the cap and the rod will fly out with some hardware along with it. At this point, you can remove the fork from the stand, remove the spring, and split the whole thing in two. To get the old seal out, all you need is heat and something to carefully pry it out with. I used a hammer. I then gave the outer forks a nice bath with nothing but hot water and compressed air. I boxed up the internals for now because I had a plan to change the fork bottoms from that faded and scratched up black color to a more classic looking raw aluminum color. Turns out some easy off heavy duty oven cleaner will absolutely destroy anodizing, but it'll also eat aluminum, so be very careful when you're using it on aluminum. Do small controlled applications like this as opposed to just dipping the whole thing entirely. So you can see that after a few rounds of oven cleaner and 180 grit sandpaper, the black was completely gone. And after several more rounds of sandpaper all the way up to 3000 grit, the bottom had that classic look that I was going for. I'd like to note that I wasn't going for that mirror finish, and not even a brushed finish, just a clean raw aluminum color like they used to do in the 90s. And maybe with some small patina just for effect. So instead of using polish and then having to keep polishing it over time, I went with the clear coat route. Basically, the polish would look better, but only if you have the time to maintain it. Clear coat doesn't look as good, but once you do it, they look the same permanently. There's nothing to maintain. Only thing left to do at this point was to install the new seals and put the forks back together. You reinstall the seals by simply banging them in safely with whatever you have. I'm using 5-weight fork oil as recommended by Suzuki. You pour a bunch in at first, so you can bleed the air out of that inner rod. Once you start to only see oil come out and you stop feeling air come out, you know that the system is bled. At that point, you actually have to set the oil level permanently. So for these forks in particular, in 04, 05 GSXR 600 or 750, you run 130 millimeters for the street, according to Dave Moss, a suspension guru. This syringe tool has different numbers that you probably can't make out on the video, but I set that ring to 130 millimeters out and I got to set in the level. When a syringe fills with oil, you return it back to the bottle because you can actually still reuse it. But once you start sucking up air, then you know that the oil is at the correct level. When it came to reinstalling the spring and the cap, there's actually a rod tool made by Motion Pro that makes this a lot easier, but it's just something that I don't have, so I just had to use a needle nose to fish out the rod. And just like that, the forks are finalized and I was pretty much done with that. The brake system will be silver as to match the fork bottoms and they should look pretty good together. Now, I have a bit of a surprise plan when it comes to that. It'll be controversial, I think. I forgot to mention too, the rear wheel actually came, so nothing's stopping me from finalizing the wheels too by sending them off to the powder coater. Maybe that's the next step. And maybe then that'll lead me to finishing the front end completely, you know, with the controls, the headlight, the handlebars, everything. What do you think? Hell, what do you think of this whole episode? Let me know in the comments. Thank you for watching. Thank you to the patrons. Thank you to New Zealand's finest, Mr. Mikey. And thank you, Common Sense. I'll see you in the next one. Hope you enjoyed.